Hello and welcome, everyone. So
Hey,
we're going to
Nathan.
go ahead and get started. My name is Nathan Heston. I'm joined by my colleague, Daniel Moyer. We're technical trainers at Briggs Stratton Energy Solutions. Good morning to you, Daniel.
Good morning, Nathan. I want to remind everybody that this class is NABCEP accredited, so we will be issuing NABCEP credits. At the end of this presentation, our email will pop up, and so go ahead and email us, and we'll get you the credits. Also, this is being recorded, so everybody's going to get a copy of the recording, a copy of all these slide decks. There's a lot of useful links in here. And lastly, if you have any questions during the talk, please put them into the Q&A. Chat has been disabled, but the Q&A is open, and we'll be happy to take some of those calls as we go, questions as we go through.
And Daniel, you'll monitor those as well, and feel free to stop me if we've got some good questions that we need to share with everyone. We do have a large slide deck here, and you'll find that I'll go a little bit fast in the beginning. The focus of this talk is going to be on programming and less so on wiring. So if you're interested in learning how to wire our battery banks together and wire the communications together, we do have other trainings on that. I encourage you to check out our YouTube channel, where we post recordings of all these past trainings. So if you have not already been introduced to our new battery, I say new, we released this in May, and we've been seeing the majority of our installs being done with this new battery. I can confidently stand in front of you here today and say I'm a big fan, and we've been having a lot of success with this battery. Very few issues with the battery and the installations. Most common installations are on the communications wiring. So I want to point out that there are resources on our website for how to wire the comms with this battery. It is a very easy installation. You'll find that this battery, without any wires, without any cabling from battery to battery, goes together very quickly. I've put together a battery stack, including the wall brackets and the floor brackets, and got the whole thing mounted in less than 10 minutes. A typical time for an installer in the field might be more like 30 minutes or so, getting this battery up on the wall. Point out it's an outdoor rated battery. Outdoor rated battery, IP67 ratings. This can be installed outdoors. It will charge starting at 14 degrees Fahrenheit all the way up to 122 degrees Fahrenheit. So it's a very broad charging temperature window. It's suitable for outdoors in many locations. If you're in a very cold location, you might want to install this indoors. It's a wall mountable battery, so I don't have any picture on the screen showing it with the wall mount, but you can mount this battery on the wall, get it off the floor, and so it's quite versatile. The majority of our pairings are happening with Sol-Ark, and we're pleased to announce this partnership with Sol-Ark, in which we're recommending Sol-Ark inverters for closed loop communications and pairing with this battery to complete your ESS system. And there are a lot of great features about the Sol-Ark, and you'll find that we're going to talk about Sol-Ark and programming the Sol-Ark through much of this talk. Daniel, what do you like about this partnership with Sol-Ark?
I like that there were two American companies. Sol-Ark is down in Texas. We're up in Milwaukee. I think it's really great. I really like partnering with Sol-Ark because they were the first to the market with a solar hybrid inverter. So all the parts and pieces, the charge controller, the automatic generator start, the inverter charger, are all built into one piece. So really excited to be partnering with them and sharing to everybody today on how to program them properly to work with our batteries.
Yeah, I like having the American technical support available from both of our companies. You'll find that our tech support team is quite well versed in the Sol-Ark software. It's really a premium inverter, as you said, that has everything built in. And Sol-Ark often refers to it. We did a joint training this Tuesday as the Swiss Army knife of inverters, and really that's true. You've got AC or DC coupling with this inverter. You've got a 200 amp pass-through on the inverter, making it suitable for whole homes. They were the first to come out with that. Others are trying to follow suit, but Sol-Ark really has put together a great inverter in that 15K here. And of course, there are other options for smaller systems as well. I like that this inverter can be paralleled. You can parallel up to 12 of these inverters. You can do 3-phase or 2-phase power with these, or split phase power with these inverters. So you can do 208 3-phase, which I use a 15K in my shop to do 2 legs of 208.
I would also argue that we're one of the best inverters to integrate generators as well. And Briggs & Stratton is well known for making lots of generators. And so there are other trainings where we dive a little deeper into that topic.
Great point, and I am going to get into programming for generators in this talk. So if that's something that you do, keep that in mind. And if you have not been doing generators together with ESS systems and solar, you might find it's a very easy pairing to make, especially with our high quality Briggs & Stratton generators. So we have put together some packages to guide homeowners and how much backup time they expect to get. These packages are based on the different Sol-Ark inverters that are on the market for low voltage, the 8K, the 12K, and the 15K. By far the most popular so far for us has been the 15K, which offers the ability for whole home backup. But for off-grid systems, an 8K or a 12K might be completely sufficient. You know, customers with a tiny home or with a cabin don't need that 200 amps of pass-through. Off-grid, you know, it's less necessary, and so we see plenty of installs still happen with the 12K inverter and the 8K inverter. Backup times here are based on a percentage of the average U.S. household power demands being supplied by the inverter. So both the 8K and the 12K inverters are typically used for partial home backup. We would estimate 50% of the loads in your house would be backed up if you're running a typical U.S. residential grid-tied home with an 8K inverter. And that would give you about 10 hours of backup time, 10.8. And you would put, you know, many of those loads on there, but not necessarily the water heater or the pool pump or those kind of things that are very demanding, maybe even an air conditioner, right? You can back up about 75% of the average home with a 12K inverter and expect 14.5 hours of backup with two of those Briggs 6.6 batteries. Two of those batteries there is about the size of a typical Powerwall, 13.5 kilowatts, 13.33 kilowatt hours there. And then the 15K is the most common backup choice of our customers, where you can do that with a single stack of 3 batteries. Looking at about 16.4 hours of backup. Of course, that does not include solar. So if you have solar power, you can greatly extend the amount of backup time. And in fact, with a house like mine, you would get through from day to day. You cover the nights with the battery, cover the day with that solar. But you can, of course, add more batteries, and each additional 6.6 kilowatt hour battery that you add will add about 5 hours of total home backup. Again, this is not a talk on sizing or wiring. We're going to get into programming, but let's start at the basics. What is an energy storage system? An energy storage system really it means a battery system, and batteries are DC systems. They do need to have an inverter to make that usable for most electrical loads in the home, which are AC, of course. So at the heart of your system, the device that manages power is a hybrid inverter like that Sol-Ark that I'm showing. And then the storage system, the storage tank, the workhorse is that battery. So we're recommending you use our stackable 6.6 kilowatt hour battery, but keeping in mind that Sol-Ark inverter pairs nicely with our other batteries like our 4.9 and our 3.8 amplify batteries with closed loop communication. And certainly you could use it with other batteries like our 5 batteries if closed loop communication is not as important to you. The 5 batteries have been very popular for large systems and off-grid installs and lead acid replacements. So that inverter is responsible for managing multiple sources of power. We're not going to spend much time talking about but how to connect those today, but we are going to be talking about, once you have those connected, how to program them. So solar power can be brought in from the inverter. Now, this could be in the form of a AC coupled system, in which you'd be looking at a solar power that already has an inverter, maybe a string inverter, or microinverters, like, you know, something like the N-phase system. So SolarEdge, N-phase are very common grid-tied systems, but there's no backup to those. So if the grid goes down, you can't use that solar. Additionally, you could certainly integrate a generator, and we're going to talk about how to program and integrate the generators for these ESS systems. So that inverter is capable of using multiple sources of power at the same time as well. So that's something to think about, and that's different from generators. With a generator backup system, you're looking at either or. With a battery backup system, you're looking at and, right? So I'm using solar and I'm using my batteries to cover the load, or I'm using solar and the batteries and the grid to cover the load. Or I'm using the solar and the grid to cover the load and I'm charging the batteries. So the Sol-Ark is capable of managing all of that, and you don't necessarily need a transfer switch. So here's a wiring diagram. Again, I'm including these so that you have these slides. We're going to send out the slide decks to all the registrants for today's webinar. This is a wiring diagram for a smaller partial home backup system like a Sol-Ark 8K inverter. There are, of course, DC connections here where you're running DC between the battery and the inverter. You might also have solar where you're running DC solar to the inverter, or potentially AC solar to the inverter through the gen port. And then you would do a partial home backup here. So you would feed that 8K and a 12K inverter with a 60 amp breaker out of the main loads panel. Keep in mind the 120% rule when you're looking at feeding back to the grid as well. So you can't feed more than 20% above the bus bar ratings back through the load panel.
And that's why I like Sol-Ark. Nathan, you asked me earlier, is that some of these power control systems where they're able to limit the amount of power that's being backfed to the main panel, right? So 120% rule, like Nathan's talking, 200 amp, 200 bus, that means we could have a 40 amp breaker. And you see in this diagram, we put a 60 on there. That allows us to draw 60 amps and pass it through to that essential load panel. But in the programming, which Nathan's going to share here in a minute how to program this, we're never going to send back more than 40. And this has been vetted and tested by UL, so we're allowed to do this.
And not all inverters are, right? I know I was talking with an installer 2 days ago, and he was using an EG4 6 kilowatt inverter, a pretty popular inverter that can be parallel, but it's not listed for PCS control. And so it's much more restrictive in how big that main load center is. You probably have to do a main panel upgrade if he wants to.
Or derate the breaker, or maybe upgrade to a 225 bus bar.
Right. So if you don't want to upgrade that main panel, then you're going to have to go to a derated breaker of 40 amp maximum for a 200 amp house, or 20 amp feedback to the grid. But the point here is that the Sol-Ark inverters are rated for power control system regulation. Let's look at a 15K. We'll spend most of our time talking about the 15K here just because it's most popular. This gives you a rough idea of what the wiring is, what the gauges should be. Of course, we are recommending this based on copper wire sizes. So 3/0 if you're making that 200 amp connection with copper. If you're doing that with aluminum, you would want to upgrade that to 4/0 aluminum. But notice here that there is a gen/smart load/micro inverter port on the 15K inverter. And we're going to talk about using that port. It's labeled gen, right? Or a generator input, or if we want to bring that generator somewhere else, or we don't have a generator, we could use that as a smart load panel, an 80 amp continuous smart load panel that could be shut off based on battery percentage. Or if you've got solar already on the roof and you've got a solar edge or a end-phase system, you might use that port to bring in microinverters. And so string AC coupled system, for instance. And notice the big difference here is we're not feeding the inverter out of a load center here. We're running this through a service disconnect, breakered or fused, overcurrent protection service disconnect. Your main connection between your neutral ground bond will occur here at that service entrance. And then you'll run those 3 cables, the 4 cables, the neutral, the leg 1, leg 2, and ground into that Sol-Ark inverter. And then all the loads in the house here would be backed up through the main loads panel. So again, if you're interested in learning more about wiring this, we can go through that in other trainings. I'm going to continue to move quickly here. If there are questions, feel free to ask them. If we want to put microinverters on our system, here's a wiring diagram out of the Sol-Ark manual. You would do that through that gen port, as I was mentioning. You could also use that gen port to do a 2-wire start generator, which would automatically start and stop based on battery percentage. So instead of running that generator anytime the grid's down and burning a lot of fuel, you can start that generator up, use it to run the loads of the house, charge the batteries, and then turn it off quickly, save the fuel. So this is a wiring diagram for that application of the grid port. You can also bring a generator and still use 2-wire start through a transfer switch. So you might go out to a home, they already got a transfer switch on the wall, they've already got a generator there, but they want to add battery backup, make that generator more efficient, increase the lifetime of the generator, decrease fuel consumption. And so you could add a battery backup system after the transfer switch. And so this is a nice way to do it. Of course, you do have that cost of the transfer switch if it doesn't already exist, but this leaves the gen port, as you can see on the screen, completely open, right? So now with a gen port open, we could use that for a sub panel. We could do load shedding with that sub panel. The connections for the batteries, we do have an energy track gateway that you'll have to run communications to, and that allows you to monitor our batteries at the module level. And in fact, sub-module level, you'll get information about the batteries, various things, including state of health, balance, low cell voltage, all that kind of thing. There's a lot of information that comes through that energy track gateway, as well as over there air firmware updates that constantly enhance that user experience, giving you more and more development as time. And we own and develop our own software. Our data is housed here in the US. And so you can rely on a secure service through an American company for continued performance, right? Connection for the Sol-Ark, the battery does have closed loop communications with the Sol-Ark, and you'll make that directly through a blue dongle. All of this is included with that purchase. So that the dongles there are going to come with the controller when you buy the 6.6 battery. On the right side of the screen, showing what that wiring bay looks like, we're showing that with a couple of 4-aught cables there. There is a grounding cable there if that's required by your AHJ. That is not a requirement for the install. This is a DC battery. So unlike an AC battery, there's not necessarily a grounding requirement. But that cable is included as well. If you're doing multiple stacks of batteries, maybe you're doing a 15K with 3 stacks of 6.6s, we're going to daisy chain those batteries together. So the computers inside each of the modules talk to the controllers, and controllers talk to each other. And so we want to make sure we have this closed loop communication between each of the battery modules. And we can do up to 6 stacks right now. So that's our current limitation. And so the wiring for this is fairly simple. It looks like what you can see on the screen there. Again, it is important that when you are making these connections that you use cables that you know are good. I'd say the most common issue for our tech support team is installers that are wiring up their own communications cables, doing their own crimping, and maybe they get a couple of the twisted pairs switched, or maybe one of them gets severed when they're pulling the cabling through. We also recommend that you use shielded pairs, right?
Yeah, that's exactly right, Nathan. So you can run the Ethernet cables. Cat5e or Cat6 is shielded, so you can run them through with the power conductors inside the same conduit. So if anybody's looking for an excuse to buy another tool, or they want to put something on their Christmas list, this network tester that you see on the screen is just one of many examples that will allow you to save a lot of headache, test those cables out. It should be there right next to your multimeter. It's going to save a lot of troubleshooting time because maybe the wire got crimped or you didn't do the pairing correctly.
Yeah, and I think this is the one that I have. I believe I spent about $30 on a Klein Tools tester, and each time I make a cable, I make sure to test it. I'm probably not as good at making the cables as some others. My eyes and hands aren't quite what they used to be, and so it's nice once you've made a cable to test it out. So thanks, Daniel, for sharing that Klein Tools option. That's available at your big box stores. There are other examples as well, but it's important that your installer have this on hand when they're doing wiring.
Yeah, and if any of the installers on this call do have one, put it in the Q&A. Let us know what your favorite brand is, and we'll be sure to share it with everybody else.
Yeah, thank you. And we're going to have a quick look at our connections here. So when you are making those connections to a Sol-Ark 15K, you've got your battery connections on the left side with your DC breakers there. The communications wiring is all in the center on that comms board there, and you can see the MPPTs, the orange, the orange cam lock connectors for those. And then above that, that's where your accessories get wired in. We've got things like automatic generator start, the rapid shutdown button, the CTs get wired in there. If you're paralleling multiple inverters, we don't have time to get into paralleling much today, but essentially you'll daisy chain using those parallel comms, RJ45 connectors there on the left side of the control board. And then if you're using our 6.6 battery, of course, you want to have that CAN bus communication coming in on the right side there. So again, this is what those connections look like. You'll get a copy of these slides. This information is available in the Sol-Ark manual as well. Everybody's going to make use of pins 3 to 6 there on that comms board. That's the CTs. Those come with your Sol-Arks, as well as BB there. That's your rapid shutdowns. If you're integrating a generator, you'd use pins 7 and 8 for that 2-wire start. That's a normally open dry contactor, and those 2 pins short, and connect to each other, giving you a closed connection in the event that the battery is below your set point voltage to charge the batteries with. So relatively easy on the wiring there. Again, we have trainings on that. If you're interested in going through those, check out our YouTube channel. But let's look at the initial battery and inverter setup. So let's suppose we've got everything wired up as we want. We're going to configure the inverter to talk to our SimpliPHI 6.6 batteries. You can do this right off the main screen. You can also make changes through the My Sol-Ark app to the programming set points on the inverter if you'd like to do this remotely. But most installers are going to use that front screen of the inverter to do their initial programming. There's also information available from the battery through the LED lights that you can see there. And we can talk a little bit about that information as we go through. But the way we get into the programming mode here is we hit that settings button in the top right corner. That'll allow us to get into the settings of the inverter and allow us to make those changes. Once we get into those settings, we need to let the inverter know to expect a communicating battery. By default, the Sol-Ark comes programmed without the BMS lithium communications box checked. That's what tells the inverter that you've got a battery that's trying to communicate with it. And if you don't have that box checked, the inverter potentially will not give the right signals on the CAN bus chain, and that can prevent the batteries from working appropriately. The batteries, when they're connected with those Ethernet cables into a closed loop configuration, are expecting communication from the other end. And so if you don't use the dongle, or if you don't have this box checked, those batteries might not be producing power, right? They are protecting themselves because they're not seeing what they're supposed to. So to get this set up, we're going to click on the battery setup. So in the center of the screen, you see that battery setup tab. Notice that there's no lithium battery info green box there above that Sol-Ark on the middle screen. And that's because we don't have that BMS lithium battery info box checked yet. So we want to go into the battery tab of battery setup and check that box that says BMS lithium battery. Once you have done that and click OK, OK is save on a Sol-Ark. So if you don't click OK after making changes, it will just revert to what it displayed before. So it's important to keep that in mind. Click the OK button. That means save. So once we've checked that box and clicked OK, you should see the screen change. And you should see, for a stack of 3 batteries, you should see a battery capacity show up. And so for 3 batteries, it'd be 398 amp hours. There is a table in the manual that will give you the amp hours of your batteries based on the size of your stack. Daniel, I believe it's 133 or so. I guess we could do that math, 398 divided by 3, but it's not an exact number, but it's around 135 amp hours.
132.6. And so just to summarize that last slide, Nathan,
yes,
you got battery, you got your inverter, right? Before you plug in the COM cables, turn the inverter on using grid power. Make the changes that Nathan just talked about, right? Go ahead and check the bat lit.
So leave those DC breakers of the batteries off. And so you've done this. Yep.
Go ahead and plug in after you've done this, go ahead and hit OK, save, then connect the comms, then turn on the batteries, and you should be seeing the voltage. Like Nathan just talked about, you should see that automatic population of the battery capacity. If this is an off-grid system, there's no grid, go ahead and use the batteries without comms connected to power up the inverter, make those changes, and then connect the comms cables. So a little bit of a different procedure there, but the idea is before you make the communication connections, you gotta hit the BMS lithium bat. Otherwise, the batteries aren't going to come alive.
Yeah, and one more point to make here is when you first connect a power source to that Sol-Ark, the Sol-Ark screen will turn on, but the load output of the inverter is not on until you hit that start button on the left side of that 15K or on the center of an 8K, 12K, right? So don't turn that power output on. We're not going to support loads yet. We're just going to get the comms set up, and we're going to get the programming done first before we hit that start button. So once you supply grid power, the screen will come on in that inverter automatically. Same if you're using battery power, the screen will come on automatically, and then you can hit that start button later. Okay, so once we've done that, we expect that battery bank capacity to show up. There's another screen I'll show you that's going to come, but we'll also expect to see a used battery percentage selected. And so Sol-Ark uses either a voltage or a battery percent state of charge for programming set points. The most homeowners prefer to see things done in a percentage, a state of charge percentage, and it's a little easier to keep in mind. Unless you're an expert on the LFP discharge curve, which is relatively flat, it is a little bit hard to do this programming based on a voltage. The other thing to keep in mind is that curve changes based on the load, whereas the state of charge doesn't. And so we use, by default, you'll see the percentage selected. Now, the other thing we can see on this screen here is that we have a maximum amperage charge and a maximum amperage discharge, and we want to go ahead and set these. The setting for the maximum amperage charge and discharge, of course, depends on how big your bank is. This is a global setting, and that global setting that's there includes solar, it includes charging from the grid, it includes charging from the generator if you're in a state where you're charging from the generator. So this is a global setting where it's all sources of charging combined: AC solar, DC solar, grid charge, etc. So basically, essentially, think of the max amperage of charge here as solar plus any AC charging source. And the max amperage of discharge is the maximum rate that the batteries will discharge under any condition. Now, we can restrict these based on the limiter tab later on with programming, and then we can restrict how quickly we charge from AC if we want to do that at all. We also want to have that activate battery box checked there. The activate battery box will allow the inverter to wake up the battery if solar power becomes available after you've gotten to a shutdown based on fully draining your battery bank. So it'll allow the inverter to start that battery up if the battery's gone through a shutdown. Daniel,
It should be notable, Nathan.
Right?
Yeah, so what we're looking at is the appropriate settings for whether in the charge or the discharge based on how many batteries you had. I will note, and I was going to just make this point, Nathan, that the max you can do on a Sol-Ark 15K, a single one, is 275 amps. So you're never going to get more than that. Nathan, what would we have to do if we have multiple inverters? How would those settings look like?
That's a good question. So we're not going to spend a lot of time on programming paralleled inverters here, but this is the charge and discharge settings are per inverter. So if you had two inverters, you would want to split that number in half that's on the table on the right. And I'll also point out to you this. The table on the right is the maximum values. You can, of course, set these lower if you want to. And in fact, Daniel mentioned that a Sol-Ark 15K is only capable of 275 amps. It's actually with a 48-volt battery, it's going to be limited. A 16S LFP battery, for instance, it'll be limited to 12 kilowatts from the battery, which is be about 250 amps. So the 6.6 batteries, if you've got 3 or more, are fully capable of handling all that the Sol-Ark can drain from it or throw at it. The other thing I want to mention here is that the battery bank capacity. So Daniel, you asked if you have multiple inverters. So if you have multiple inverters, the battery capacity will be the same on each inverter, but the charge and discharge rating you split in two. Right, that charge rating is per inverter. So if I'm charging at 195 amps and I have 2 inverters, it'd be twice that. So that's why you want to cut that number in half. Those settings are per inverter. Okay, so let's go into the charge tab. And the charge tab, this allows us to set individual charge and discharge rates based on AC sources. So the gen charge column on the left there, so you see the grayed out box of 49 volts. That's because we selected use battery percentage. So if you had a different battery and you had selected use voltage, you could create that set point based on the voltage. We're going to use percentage here. And what that number of 40%, that start percentage is it starts charging if the battery drops below that percentage. So let's suppose I've got a generator on the system and I've entered 40%. If I drop down to 39% battery capacity, battery state of charge, it would use the generator to start charging at 60 amps. So it would throw the two-wire signal to start. It would start up the generator. It would charge at a maximum rate of 60 amps. Now, keep in mind that it could also be charging from solar, and these global limits here would allow an additional 135 amps to make a total of 195. So it will not charge more than that 195, but it will do 60 amps here from the gen port. The other thing to keep in mind as we're doing these settings here is that setting that says, it does say gen charge there, that's actually the gen port. So if you had AC coupled solar coming in through the gen port, that would be the rate you're allowing the charge to occur on the batteries from the gen port, and any excess power would have to be sold back to grid if those were microinverters or a string inverter that's coming in with an AC coupled system. So that's really the gen port settings. If I had a generator on the grid port, I would use the grid charge box here for a set point for grid charging or generator charging on the grid port. So keep that in mind. These checkboxes and columns really refer to the location, the charging location where the power is coming from, either the grid port or the gen port. We do have the grid charge box enabled here, that if you have a utility power, that would be charging from the utility up to a rate of 100 amps if you're anything less than 50%. So this might be a system where you want to have at least a 50% reserve. And so that would allow grid charging if solar is not capable of maintaining that battery percentage or it's nighttime. And then Daniel, what's the gen force box that you see in the bottom left corner there?
Well, that's a way to annoy your neighbors. You can go ahead and hit gen force. That will automatically send the two-wire signal to start to the generator. And if the generator is in automatic mode, it will start up. Should be noted, you also see gen exercise there. That can be disabled by just setting the time to 0. Briggs Stratton generators have a very unique feature, eco size, and I don't have enough time here to talk about it, but I would leave the exercise function of the generator to the generator itself. And you can do that here as well. Another thing to note, Nathan, is that once that generator starts, in this example at 40%, it's going to charge all the way up to about 95% state of charge.
Yeah, that's a good point. And so if you've used gen force to start it up, you can uncheck that box and click OK to stop it. But yes, if we've reached a state where the two-wire signal start has started the generator, we will complete the charging cycle, or at least get it to about 95% before shutting the generator off. On the battery discharge side of things, this is where we can tell the inverter how low to discharge the batteries, like what depth of discharge are we looking at. And what we see on the screen is a 10% depth of discharge. For systems that are going to charge and discharge every day, we recommend, what number would you recommend there, Daniel, for a shutdown voltage or shutdown percentage?
Well, a shutdown, right, is a little bit lower than what we'd want for low battery. And so
Yep.
I think the figures here you got are pretty good, right? We're going to low battery at 20, right? The warning, we're going to shut down at 10, still leave a little bit in the battery. And then we're going to want that battery to come back up and get a good charge on before it reconnects lows, which is the restart.
And one thing I would do, I would change on the screen here, that 45-volt battery empty voltage there, that's where the inverter takes a 0% state of charge reference. So if you hit that voltage, your state of charge will reset itself to 0% state of charge. I believe that's closer to about 47.5 volts on our batteries. And that number depends, it varies a little bit because there can be some imbalance between the cells of the batteries that get balanced off when the batteries top off. The shutdown voltage there, what that does, just so everybody's clear, when we hit the shutdown voltage, that's when the inverter actually shuts off the loads. So it turns loads off. It doesn't actually turn the inverter off. And the inverter will keep running once you hit that shutdown voltage. And that does have the potential to drain the batteries. The inverter itself will use about somewhere between 50 and 60 watts to stay idle. Low battery is going to give you an alarm. So if you've got the beep enabled on a Sol-Ark inverter, you'll hear it beeping at you. Hey, your battery bank's getting low, right? And then that restart voltage is, or that restart percentage is, if your inverter has hit shutdown because there's a grid down event, you're operating off batteries, but solar comes out and it starts to charge the battery bank up, it won't turn the loads back on until you hit the restart percentage. I'd probably set that closer to 25%, a little bit above my low battery. It gives the battery a chance to start up, and it makes sure that that solar is strong enough to kind of cover your loads before turning loads back on, so you don't have this oscillation on, off situation. Battery resistance there is going to come in automatically. It's going to be about 8 milliohms for a 3 battery stack. It'll change based on your battery bank size. And the battery efficiency overall should be about 99%. The efficiency does depend a little bit on how quickly we're charging or discharging, but for a typical customer, they can expect about 99% efficiency on the charge.
I would also say the float, absorb, and equalize on that left-hand side will auto-populate as well.
Yeah, no, they are grayed out right now, and they're grayed out because we've used the battery percentage. But if you have a different battery bank and you need to set based on those, you can reach out to our tech support team or consult our manuals for recommended values for our other batteries, like our PHI or our SimpliPHI batteries. Now, after we've got appropriate communications with our battery bank, we've finished programming the battery setup, we hit OK, right, to save everything. Then we'll see an additional item on the menu, and this is lithium battery info. And this is information the battery bank is sending to the inverter. And so you can see on the right side of the screen there, that's a picture of my inverter screen at the shop. And that's showing the information that the batteries are sending in the inverter. If you do not see that screen, something's wrong with their programming, right? Or something's wrong with your wiring, and you need to go out and buy one of those cable testers that Daniel was talking about earlier. You got to make sure your comms are done appropriately. If you don't see that button after enabling the lithium battery communication tab, something's wrong. Okay, so all right, let's talk about how to do a load shed sub panel. So this is a nice feature of a Sol-Ark, unique to the Sol-Ark that I like, and it allows us, if we have not used the sub panel for a generator or AC coupled solar, it allows us to use that generator as an 80 amp 240 volt load shedding panel. And so we can turn that on or off based on our battery percentage. And we're going to get into programming that. So if you've got something like maybe a pool pump that's circulating water and just filtering the water, you don't need to have that on during a grid outage event. And so we might put that on a sub panel and say, hey, grid outage event, yeah, we're backing up the whole home, but we're not going to back up that pool pump or the spa, maybe even a car charger. You might want to be a little bit liberal with a car charger and allow it to charge your electric vehicle up, but you don't want it to run if your home backup battery is below a certain percent. You can put an air conditioner on there if you don't care about air conditioning in a grid outage, or you're worried about it consuming all the backup power you've got. Hot water heater you might throw on there as well. Depends on how important that hot shower is to you, I guess.
I would argue, Nathan, maybe the hot water heater is one of the best ones. So what we're talking about here is a grid down scenario. If we have grid, the grid's going to charge the batteries. You're never going to the smart load output's never going to kick in. So when we're grid down and the batteries start to get drained, what we can do is eliminate a load based on the state of charge of the battery. It's kind of like the old off-grid days where it's morning, batteries are drained by noon, 1 p.m. The solar has fully charged up the batteries. Go do your laundry. Go start cooking the turkey in the oven. Thanksgiving's coming up, everybody, next week. But use that load. So it used to be you'd have to change the behavior, but with this smart load output, it's done automatically for you. And the reason I like doing an electric water heater on there is, if you think about an electric water heater, it's probably one of the cheapest batteries or energy storage methods you can do, right? Make all that hot water during the day when you have excess solar. By the time the evening comes along, the battery drains a little bit. It's going to cut off that electric hot water heater. That tank is warm, it's insulated, and it's going to give you that nice warm shower in the morning if you're not using too much hot water to do dishes after Thanksgiving dinner.
That's a great point, Daniel. What I like about this is so a couple of things, as Daniel said. I mean, if you're getting a good feedback rate by selling your excess power back to the grid, but then it's different, right? But in a grid down situation, you can't sell the excess power back to the grid. right? And so Daniel mentioned earlier, you know, if you check this box here for grid on grid always on, what that does is it'll keep that smart load center, that smart load panel energized anytime the grid is there. So it'll just use pass-through power and solar power to power those loads with a grid up situation. So if you've got that checked, this only applies to when the grid is down. So as Daniel said, grid down situation, as long as your batteries are charged up, now we can set this this load off percentage to whatever we like it to be. I've got it set to the recommended values there of 80 and 90%. So what happens is if the battery bank drops below 80%, it'll kill that sub panel and it'll take all those loads down. But as Daniel said, if those batteries are topped off, your solar's providing plenty of power, they're above 80%, it'll turn that water heater back into a energy storage mechanism, just like Daniel said. So it's a really nice feature of the Sol-Ark, and you've got some programmability there to be able to adjust that. Now, you'll notice that there are other check boxes for AC coupled solar, that kind of thing, and we're going to get to those in a minute. So here we are. Let's suppose you've got AC coupled PV. I'll give you a couple of examples when you might want to use that sub panel, or sorry, that port on the inverter as to bring in AC coupled solar. Let's suppose you've got an old solar array, and it's got a grid tied inverter on it, where you're just essentially pumping all the power from that solar array into your main load panel and sending everything back to the grid, but there's no backup. So that solar array is only on when the grid is on, and if the grid's off, that solar array cannot supply the loads of your house, right? So if we come in and we add a battery backup system, we can AC couple that solar without having to change that old inverter out, without having to have to make changes on that solar array. Another example is if you've got micro inverters up on the roof, you don't want to have to get up on the roof, do more permitting to change that solar array and lift off all those panels, pull the micro inverters off and change them. We can keep that AC coupled solar alive in a grid down event. And the way we do that is we bring that AC coupled solar. Now the AC coupling here refers to coupling the solar with 240 volt AC to the battery bank, right? So we're bringing the solar in as AC instead of DC. So this AC coupled solar here means we bring our solar in as AC through the inverter gen port. And then we can keep that alive because the Sol-Ark inverter is grid forming. That means in a grid down situation, the Sol-Ark will create a grid, right? It will form a signal that those micro inverters or that string tied inverter thinks is the grid, keep it active and allow it to produce power in a grid down event. So how do we program that? Well, it's relatively easy. We do have to use the gen port for this. You can see on the right side of your screen, it's got a microinverter battery there, and that the loads of the house in a grid down event, the grid would not be there. But there are a couple of things we do on the Sol-Ark inverter. So the first thing we do on the Sol-Ark inverter is we make sure that we go into the limiter and we check that box for grid cell. You cannot use the AC coupled input to the generator unless you've got that box grid cell checked. That allows any excess solar that those string or microinverters create to go back to the grid. So you do need an interconnection agreement for this, but your customer is already going to have that if they've got a grid tied system, if they've got a string inverter or microinverter system, right? So the Sol-Ark inverter can control that solar in a grid down situation. So we're going to have that box checked for AC coupled solar input on the generator. We're going to keep that box checked for on grid, always on, right? When the grid is there, we want to have that AC coupled port active, right? And then we will turn on and off that AC coupled solar based on the battery percentage. So we have to be a little bit careful because unlike MPPTs, where you can regulate the output, for AC coupled solar microinverters, their job is to produce as much power as they can based on the available sunlight. And that power has to go somewhere. So in a grid down event, we want to make sure that we can send that power to the batteries. But if we send too much power to the batteries, when they're already charged up, we could damage the batteries because it'll charge them too quickly. So what we have to do is we can turn that battery charging on and off based on battery percentage there. And so what we do is we turn off that smart load port. We turn off the AC coupled solar when the battery is above 90%. If you have a big battery bank, you could push that maybe up to 95% or so. But for a 3 battery system and a single Sol-Ark, we recommend about 90% there. And then that will be on whenever the bank is below 80%. So that, again, the discrepancy between those two numbers prevents the rapid turn on and turn off there.
I was at a site yesterday, Nathan, actually I should say last week, where we had the AC coupled solar on the load panel, not on the gen port. It's totally acceptable, and you see the little checkbox there. I will say that by doing that, we didn't have the visibility on the Sol-Ark screen of the production of that AC coupled solar because it's on the loads panel, right? Some of that energy being produced or power from that AC coupled solar could be consumed by loads. So we're just seeing the aggregate there. But absolutely, just the way the lay of the land was at that install site, you can still AC couple on the load side as well.
You can AC couple on the load side, and Daniel pointed out that because that power is not running through the inverter doesn't have a good way to keep track of it. But I also want to point out, if you do AC couple on the load side, you cannot use the gen port for something else like a generator. So keep that in mind as excuse me.
And you can monitor the production with the Enphase app or the SolarEdge app of the AC coupled solar. It's just not through the Sol-Ark.
Daniel, I'm going to let you talk through this section here.
Yeah, of course. One really exciting thing that we've can do with the Sol-Ark is bring in a generator right onto the gen port right here. Again, one of the things we want to be careful with, though, is when you bring a generator onto the gen port, using the 2-wire signal start, like we talked about, it'll start the generator, shut off the generator. But when we want to have AC coupled solar and a generator together, we have to do some unique things. So one thing to keep in mind is that we're using the 2-wire signal to start, right? Pins 7 and 8. When we feed that 2-wire signal to start into the generator, that's pins 4 and 5. We have 2 versions of our generators there. On the right-hand side, you're seeing one of our Power Protect 13K. On the left-hand side is one of our horizontal units. Those go all the way up to 26K, propane or natural gas. Next slide. So one thing I think a lot of people don't realize is when we have a generator, you think a generator, it's feeding power to the home. It's feeding power to the Sol-Ark. Well, a lot of generators, including our own, you have to feed power to that generator all the time. It's used for a couple things. One, it's used to keep the starting battery inside the generator charged. If we have any cold weather kits, like a battery warmer or an oil warmer, we have to feed power to that generator to keep it warm, keep the battery charged, but it's also using it for what's known as grid sense, where the generator is looking for the presence of grid. If it sees grid go down, it will start itself up. It will send a signal to transfer to a transfer switch and start to power the home's loads. But if we're now have a Sol-Ark and we have a microgrid in our home and we're feeding power to that generator from a backed up load panel, the grid goes out, the generator still sees the presence of grid because you're feeding it from either the whole home backup or from the critical loads. So we got to get into that controller, make a couple of little settings adjustments to say, look, generator, if you still see the presence of grid, great. Use that power to keep yourself warm, to keep that battery charged up, the starting battery. But if you do see a two-wire signal to start, go ahead and start up.
And the procedure there for disabling the auto main sensing is available there. I'll get a video linked on this slide before we send it out to everyone so that they can watch the process of how you disable the auto main sensing. Quick check on time, Daniel. We've got a little over maybe 10 minutes left, so we want to run through pretty quickly here. Again, you have the ability to set the charging rate off your generator. And why is that important, Daniel? What's a generator doing when we're pulling power through that gen port?
Well, you don't want to overload the generator. So here we can adjust the rate at which we're loading down that generator. But I think it's really exciting because we can run, most generators don't run at full load when they're running a home. So what the idea is that we can run that generator hard, run it at its most fuel efficient point and then shut it off so you're not annoying your neighbors, and then you can coast. It's kind of like a hybrid car in a lot of ways that I like to think of it.
So good point. The setting there, that's 60 amps. AC, DC, 60 amps, that's 12 kilowatts, right? Or is that a DC amperage?
That's a DC setting.
Yes, I think we, keep in mind if you're used to talking about amperages with, I guess that would be even more than 12 kilowatts. So if you're used to talking about amperages and always thinking of 240 volts, right, voltage, this is not it. This is the DC voltage. So it's going to be about, charging at between 50, 56 volts. So you could think of that 60 amps there times 50 volts, be a little over 3,000 watts of charging there. Now, we don't want to go too high because remember, our batteries can't charge and discharge at the same time. So if we started up that generator because the solar is not doing enough to charge the batteries, or you don't have solar, keep in mind that the generator also has to supply the loads to the house. So what do we have on the right side of the screen, Daniel?
Some limiters, right? So we're not overloading the generator if we're both charging the batteries and supplying home loads.
Yep. So if you've got a smaller generator, so we're limiting power there on that gen port to 13 kilowatts with that gen limit power button. If you've got a smaller generator than that, maybe you've got an 8 kilowatt generator or even a portable, you can limit the amount of power you pull through the gen port. And if we've got the appropriate settings done here, then we will charge secondly to powering loads. So if we're powering loads and we've got a 13,000 watt limit there and the loads are 10,000 watts, it will only charge at 3,000 watts. Or if the loads go up to 12,000, it will reduce the charge rate. Now, when the inverter sees no grid, that grid icon will have a signal line going down to it. That's the indicator that the 2-wire start is active. Those normally open dry contact pins there will be closed and calling that generator to start up. Once the generator starts up, you'll see the grid icon change from grid to a generator, and you should start seeing power flow. And so that you'll see these signals on the screen when you're testing things. And so when you're first setting things up, go ahead to test it. Set those percentages at points where you would get this signal to come and make sure that those pins really do close on you. So what if we want to put the generator on a grid port? What things should we be looking at? Well, there are a couple of things I'm going to tell you. So if you put the generator on a grid port, you've got to program the charge rate off the generator based on the grid charge settings. So we'll get to that in a second. We can put the generator on a grid port for an off-grid system really easily without a transfer switch because we've got no grid, right? So you can just run that generator in on the grid port. In fact, if you're in an off-grid setting, we recommend bringing the generator in through the grid port. That not only frees up the gen port for maybe a smart loads panel, but it also increases the amperage from 80 amps at 240 AC all the way up to 200 amps. So you could bring in a big generator for an off-grid system. It also, if you do use a transfer switch, don't worry, you still can use the 2-wire start feature. You still have that essentially like that hybrid generator. But you do, of course, need to have that transfer switch enabled there. And so it will only start up the generator. It doesn't start up the generator immediately if the grid's down. It starts up the generator if the battery percentage gets low enough to call for it. So the 2-wire signal to start is the same whether you've got the generator connected through the gen port or the grid port. We are going to show you another thing here, and that's that you can actually do a generator and AC coupled solar. And if you're using a Briggs Stratton SimpliPHI Choice or SimpliPHI 2 transfer switch, then you can do a lockout module and prevent AC coupled solar from sending power back to the generator alternator. We don't want to damage that.
Let the smoke out.
Yes, exactly. So that's a nice feature of that Sol-Ark there, and it's a nice feature of our Briggs Stratton transfer switches to allow us to just lock that out. So anytime that line sees the generator on, it'll lock the AC coupled solar out. It's not going to be a common thing because remember, the batteries should be charging if you've got enough power coming from your AC coupled solar. But in the event that at the early morning or end of the day, you might be having a little bit of AC solar coming in, but not enough to charge the loads or to cover the loads, and the batteries could be draining and call for that generator to start. Okay, so if we've got the generator on the utility port, just one more time to emphasize this. Of course, we've already shown you how to do to disable auto main sensing, but we do want to point out if the generator is coming through a transfer switch, excuse me, on the grid port, we do want to use that grid column to set the charge rate off the generator. So you've got it one column now. The gen charge box would be unchecked unless unless you had AC coupled solar there. So it is, if you got this is really a physical location. So if the generator is coming in on the grid port, you use the grid column here. If the generator is coming in on the gen port, you use the gen column to control your charging settings there. All right, so let's get into the limiter. We've got just about 5 minutes left, so I will go quickly through this. The limiter allows us to tell the inverter what to do with our excess solar power. And it allows us to control the battery charging. It basically allows us to control how we use the power that's stored in our battery bank. So if you have an interconnection agreement, you'll have that grid cell box checked, and you can set how much power you want to send back to the grid. This is an important point to make. If you don't have whole home backup, right, you might have a 12K inverter, and you'd be limited by the 120% rule that we mentioned earlier. So this is where you limit that power you're feeding back to the grid. So that's the grid cell checkbox there. Limited power to home is going to when the PV power is insufficient to cover the loads, the batteries can discharge to prevent pulling power from the grid. So we can limit power to the home, and those settings can be adjusted there to make sure we're not pulling power from the grid if we've got battery power available. Save that cost of electricity and use the PV power that you've stored in your batteries.
And make sure you've installed your CTs if you haven't done a whole home backup, because you need to understand what's being consumed in your non-backed up loads, and the CTs will go there. Really excited about the time of use settings in the Sol-Ark. Not only can you do different times of the day at different rates, but also you can do seasonality. And so they have really advanced controllers built into this. There is some other training where you can even do some functionality on the generator as well. But Nathan, I know we're coming up on time, but we did have a question, so I want to leave a little minute for a question. Do you want that now, or you want to wait it for the end?
Yeah, let's go ahead and take that question. We're going to get into monitoring next, but let's go ahead and take the question.
Haas asks, I understand that you set the battery parameters after connected to another power source. But I think the question is the inverter black start capable if connected to the gen or the grid?
I'm not sure. I do not know the answer to that. I don't know what is meant by black start capable.
Well, I think what that means is that, say the batteries, we have gone into shutdown, and for whatever reason, the inverter isn't supplying loads, but the inverter has a parasitic draw. You said 50 to 60 watts, and then the batteries continue to be drained by that inverter, and they go below to that shutdown voltage. If there's grid, right, the grid should be able to come back on and start charging the batteries. But
so
I don't
absolutely will. So I think that I would answer this: if you have a generator there, that the generator would turn on before we get to that shutdown. Voltage, right?
Yeah, or grid too.
You would want to make sure you program it that way. If you have solar, the inverter is capable of starting the system back up based on that input of solar. So you'll find that if you have that solar on, it will wake up the inverter. The same thing when the grid comes back on. When you first turn on that grid breaker, it will start up the inverter. So I think the answer is yes, if I understand what he meant by black start capable. But if not, please feel free to clarify for us. One more set of things I want to provide to you, and just let you know that you have this resource available when you get the slide deck from us, is that when you are programming the Sol-Ark, it's going to beep at you every time you make a change or scroll through the buttons. And if you want to turn that beep off, you can do that there. You do want to have the auto dim box checked so that you have that warranty. Keep that warranty on your screen. That'll turn the screen off after a certain number of seconds. The other thing I want to point out to you, if you've got a homeowner with happy fingers, but maybe they don't quite have the understanding they need to have, you can lock out setting changes. In the password for locking out those setting changes, I put there on the screen for you. You can also do a factory reset. So if you've got something that's if you've got something that's changed, basically, if you hit that if you check that factory reset box, click OK, it's going to ask you for a password, and you can reset back to the default settings to get you back to where it comes from the factory quickly and easily. I'm going to point this out. So like I said at the beginning, I have a huge amount of confidence in this battery. I love this new battery that we came out with. It's infinitely easier to install, and we've got some great performance out of it. It is an LFP battery, which means that we've got that superior safety from having the right chemistry, right? And I will say, you know, for 14 years, SimpliPHI Power has been producing LFP batteries and refining and improving the technology. We're one of the pioneers of LFP, and I know our competitors have switched over and joined us in that matter, but we do have the right chemistry and the right expertise here. Also point out we can put up to 6 of these stacks together on a system. You are limited to a certain number in the garage, depending on your jurisdiction. I think you're limited to 80 kilowatt hours in a garage, 80 kilowatt hours on the outside of the house, but we can do up to 120 for a single system. And those regulations are changing as well. We have a talk on codes if you're interested in learning more about those codes. I also want to point out that we have other batteries out there. So if you're interested in some of these other batteries, like the PHI and the SimpliPHI battery, one of the nice features of these batteries is that we have integrated heating systems for cold weather environments. And these batteries can go in battery cabinets as well. The 6.6 battery is designed to be a freestanding indoor-outdoor battery. But some cold weather applications, I know that up in Buffalo, we've seen some very nice installs with battery heaters there for outdoor environment. That's where my sister lives. I can attest that it's very cold. I was there last Christmas. We also have a line of high voltage batteries. So we want to point out that we do high voltage battery banks for commercial, industrial, three-phase applications. So if that's something you're interested, reach out to Daniel and I. We'll connect you with our high voltage team, which can help design that project for you. I'm going to give you this slide as well. This is a slide where we detail the specs of the Sol-Ark inverters. I don't have time to jump through the communications platform and talk about remote monitoring. I just will let you know we've got robust remote monitoring from the individual battery module level here. And then Sol-Ark has their battery monitoring platform as well, where you can look at the history and see how your system is doing. It allows you the remote programming as well. And this is information that you can see about our battery bank through that Sol-Ark app as well. At an ending, forgive me for going a couple of minutes over here. I just want to highlight to those of you, if you're interested in doing your first SimpliPHI ESS system, we currently are running a $1,000 promotion. And if you join the Elite Installer program, you can get an additional $100 off per battery you install. So that could be quite a substantial rebate here for your first system. So thank you for making it through this talk with us. If you're here for those NABCEP credits, what should they do, Daniel?
Email us, energy storage training at BASCO, BASCO, Briggs and Stratton Company is what it stands for. Email us and we will go ahead and issue your credits. Please include your full name, spell it out for us so we get the credits. Energy storage training at basco.com. If anybody needs to drop off now, please go ahead. We're not going to hurt our feelings, but we do have a couple of questions in the chat, Nathan.
That's
and
great.
we can.
Daniel, I also want to point out that go ahead and use that email if you have questions or you want to get connected to an applications engineer. So we have field applications engineers, design application engineers that will help put that system together for you, tell you what the necessary components are. So go ahead and drop off if you need to, but let's address these questions, Daniel. I'm happy to stay on as long as it takes.
Yeah, so Hans is asking, he types in two things. So I'll read the first one. He says, on the charging parameters, when there is percent or voltage listed as conditions, does it need to meet both conditions or one or the other?
It's either or. And so the use a voltage to program or use a percent state of charge to program. And by default, the 6.6 is going to set it at a percent state of charge. So it does not need to meet both. You're programming as an either or. I recommend the percentage for all of your systems. But if you're working on a non-communicating battery, you might be a little bit more accurate by going ahead and using the voltage, and we can help you set those conditions based on your system design. So a system that cycles daily, we might give you different numbers than a system that's just there for standby.
I saw somebody raise their hand. Please just go ahead and put that into the Q&A, and we'll take a question. These are great questions. If you're asking them, I'm sure somebody else in this talk is
Yes.
going to be interested in them as well. Hans continues, if we have issues with battery percentage being accurate, is that an issue with communication with the inverter or with battery parameters not being correct in the Sol-Ark programming?
Yes, so
or,
I think
or
I can
other.
jump into that. I can jump into that. So first off, the battery percentage. So I've heard rumors that with certain batteries, the Sol-Ark might not do a great job with batteries without communications of estimating what the state of charge is, and that might be user settings. For instance, you do have to put in a battery resistance, right? So when you're operating with non-communicating batteries, the Sol-Ark is trying to estimate what the battery state of charge is based on the voltage, based on the battery type, and based on that battery resistance. I do point out that these voltages vary with load. But to answer the question as completely as possible, with a communicating battery, the state of charge percentage, at least from SimpliPHI batteries, comes from the battery itself, and it will be accurate. So good question. The answer is that you should not have any problems with state of charge, because that's coming directly from the BMS inside each battery, which accurately keeps track of the state of charge. And then that is averaged in the controller. And through the energy track monitoring platform, you can see the percentage of each individual battery. We might have an example of that above. But go ahead and you see how on the left side of the screen, you can see all three of these batteries here are at 99% state of charge. But the state of charge in programming that's used by the Sol-Ark is coming directly from our controller. And it's an average of the individual battery modules that you've got. So great question. Hopefully it's clearly answered.
Haas clarifies black start batteries are dead. A problem when there is no gen or grid, off the grid. Yep. Howard asked some good questions. He asked two of them here.
So the answer is, so let me go back up to that one for the black start, and I've got a bunch of slides to go through. But under our initial programming, you see that activate battery checkbox there? That activate battery checkbox allows the inverter to wake the battery up in the event that there's no grid, the battery's hitting a low battery cutout, and the solar comes out and starts to have available power. So that black start capability is linked to that activate battery checkbox. So make sure you've got that checked, and the inverter can start up the battery and start charging it when an available solar power source arrives. So, okay, next question.
Well, Howard makes a comment. I'll read the comment first, and then the second comment. Howard says, voltage should be programmed first, then use percent values. This assures when communication fails, voltage values are used. A table should be provided.
Yes, and we do provide tables of these voltage set points. So if you check the manual, we can the recommended voltage set points are highlighted in the 6.6 manual as well as our other manuals. Technically, I agree. He's right. If you set the values first, the default for the Sol-Ark, if it loses for communication for some reason, right, whether a cable gets unplugged or a cable is damaged because you've got a happy mouse chewing on it, it should default to the voltage set points that you've got. So that is a good point, because as soon as, if a battery stops sending a percentage to the Sol-Ark, it will default to the voltage values. I didn't include that here because it's additional information, but yeah, I do agree. Best practice, Howard, is to do exactly what you said. Program those voltage values, then connect your communications and reprogram based on a state of charge.
Energy storage training at basco.com is where you get your NAPSEP certificates. Nathan, we don't have any more questions, so we are taking a break next week because of the Thanksgiving holiday. Wishing everybody a happy holidays. And then we'll come back in December and finish off the early part of December with some more upcoming trainings. Any closing thoughts, Nathan? Is it Is it pretty easy to program a Sol-Ark, right?
Once you know what everything means, that's a relative term, right? I think
Yeah.
for you and I think that we would answer that this is one of the easiest inverters out there to program. But I think we're quite familiar with those settings. So if you have trouble, reach out to us. That's what we're here for. And if we can't beat all the price from the competition coming in from overseas, what I can tell you is that we can beat out based on our customer service. So if you've got questions, you need help, reach out to us, energy storage training at basco.com. You want to get somebody on the phone, 805-640-6700 extension 2. We've got people ready to help you out. So thank you for attending, and we'll see you next time.
Thank you, Nathan.